Hi, everyone. This is Mr. Che, and we will continue with the parallel lines and perpendicular lines lesson. What I want to do, though, is I want to start off with the different forms of linear equations and just kind of emphasizing that. So here's my whiteboard here. I'm going to change my screen. And so first of all, we need to remember the three different forms of linear equations. Well, and first of all, again, another thing too is what is a linear equation? All right. So when you see an equation, right, let's just say y equals 3x plus 2. The key thing to remember is you need to make sure that you know what form it's in, or is it in any kind of form? Okay. So you have to know the features of the different equations. All right, so let's look at this equation right here. One, we realize that y is by itself, okay? Whenever variables are by itself, that's a good thing. You want to kind of have that. That's something that should kind of stick out to you, all right? Another thing is coefficients, okay? Numbers in front of a variable. What does that mean? All right, so on and so forth. And then numbers that are by itself, these are called constants. Right? So there are different features of an equation that you need to kind of recognize right away. All right. And we're lucky. You might think this is tedious and boring in a way, but we're lucky because the people before us set it up so that we could have these formulas. We have formulas to refer to. All right. And so whenever you see an equation like this, you should kind of remember that this is in y equals mx plus b form. Also to note too that the variables, both the x and y, there's two variables, right? And notice that both of them are in the first power. That's another thing to realize, okay? And so if they're both in the first power, then we know that that's a linear equation, okay? All right, so in this case right here, this is the slope-intercept form. Okay, there's also this form called the standard form, which is ax plus by equals c. Okay, and that equals, I should put equals here, equals standard form. Okay, and there's also the point slope form, and I don't really use the point slope form too much. I particularly don't really think it's as necessary, but people like it, and it refers to, I mean, it could help out with different different types of problems, but this is the point slope form. Okay, so whenever you look at an equation, look at the different features of an equation. Okay, all right, like let's just say for instance, like if they say graph x equals 3. Well, what's different about this equation and this equation? Well, we know that there's only one variable here. Okay, all right, there's only one variable, there's no y. So what does that mean? Okay, x equals 3. Well, the way I look at that is pretty much as long as if you see a coordinate point x and y, right? Each coordinate point has an x and a y. As long as the x value equals 3, y could be whatever it wants. So 0, 4, I'm just picking random numbers for y. Because as long as the x value is 3, you're good here. Okay, all right? So that's where x is equal to 3. If you have an equation y equals 2, well, as long as the y value is 2, right, you are good to go. And the reason why I always choose 3 points or at least 2 is because you need 2 points to make a line, correct? All right, so you have to start remembering and just recognize whenever you see an equation, what form is it in? And is it in any form? And why do I need to get to a certain form? Okay, well, everybody remembers y equals mx plus b. And the reason why is because it's the most useful. Okay, whenever you get the y by itself, all right, it tells you a few things. It tells you the slope and the y-intercept, hence, therefore, the name slope-intercept form. Okay, Let me show you. Let's say we have an equation, 3x plus 2y is equal to, let's say, 6. Okay, all right. Well, right away, we know that the y is not by itself. Okay, this is in standard form, which is ax plus by is equal to c. Okay, and so what we need to do is we need to convert this to slope-intercept form. Okay, now how do we do that? Well, we have to get the y by itself. Remember, the slope-intercept form is y equals mx plus b. Now, why are we doing that? Why do we need to get into slope-intercept form? Well, because by getting into slope-intercept form, once we get the y by itself, the number in front of the x tells us the slope, and the number that's by itself tells us the y-intercept. Okay? And I'm hoping that you guys remember, too, what is the slope and what is y-intercept. Remember, the slope is rise over run, right? Y2 minus Y1 over X2 minus X1. That was a lesson from last week. B is the y-intercept. Where does the line hit the y-axis? Okay, so let's go from here. We have 3x plus 2y equals 6. Okay, so now what do? We want to get the y by itself. So we subtract the 3x here. Okay, that cancels out and becomes 2y is equal to, and now I'm going to put it's really 6 minus 3x, but because the slope-intercept form has the x term first, what we're going to do is I'm going to put the 3x in front plus 6. Okay? Then what do we do next? We divide the 2 to both sides. And so y is equal to negative 3 over 2x plus 3. Okay? So now what happens here? Well, we know that this negative 3 over 2 is the slope, and this 3 is the y-intercept. Okay, I hope that makes sense to you. Okay? Now for this week's lesson here, what we're going to do is we're going to compare if two lines, okay, are parallel or perpendicular or neither. They intersect at they hit it at a point. Okay? And so let me clear this here. Okay, so let's say we have the equation of y equals 2x plus 3 and y equals 2x plus 6. Okay, well, first of all, right away you should know that that they're both in slope-intercept form. Okay, they're both in slope-intercept form. And so for the first equation, what is the slope? The slope is 2, and the y-intercept is 3, right? And for the second equation, the slope is 2, and the y-intercept is 6. Okay? So whenever you have the same slope, you know, and a different y-intercept, they have to have a different y-intercept. Okay? Whenever you have the same slope and different y-intercepts, they are parallel. Okay, what does that mean? That means that the lines will not hit each other. Okay, parallel lines are this pretty much, right? The lines do not hit each other. Okay, they will never meet. Okay, they'll just always be going alongside each other, but they'll never hit each other. They'll never intersect. Okay, so the slope, understanding what slope is and understanding how to get the slope is very important here. So if they ask you any questions, determine whether two lines are parallel. Right away, you should think slope. Why? Because if you have the same slope, you know that the lines are parallel. Okay? Now, what does perpendicular mean? Okay, there's this word perpendicular. What does that mean? Okay, a line that's perpendicular not only intersects the parallel line, it makes a 90-degree angle between the two lines here. Okay, well then how do we know if the lines are parallel or perpendicular? Okay, well you need to look at the slopes. All right, you need to look at the slopes. All right, and make sure that you guys also look in, there's there's like a PowerPoint or some examples, some things that just make sure you look at those things because and just kind of study those a little bit because that'll help you out a lot. Okay, so let's just say this. If I have line 1 here, let's say line 1, line A, this is line B, and let's say this is line C. Let's say these two lines are perpendicular and these two lines are parallel and this line is perpendicular to both of these lines. Okay, and let's make a chart here. Okay, so line A, and let's say line A's slope is 2. Okay, then line B's slope is going to be what? It's also going to be 2, right? Because why? They're parallel. All right, but line C is going to be perpendicular, and what you need to do is you need to get the negative reciprocal of this original slope. Let me say that again. You need to get the negative reciprocal of the slope. All right, so if the slope is, let's say, in this case right here, it's 2, right? And it's 2 over 1, correct? If you put it into a fraction. Well, remember what the reciprocal is. The reciprocal is you flip the numbers over, so it'll be 1 over 2. Correct? Okay, and since this is positive right here, then that means that the perpendicular slope is going to be negative. So it's going to be negative 1/2. Okay? Let's do another example. Let's say the slope of line A is 3 over 4. So it's 3 over 4 here. That means what? The slope of line B is going to be what? 3 over 4 as well. And then the slope of line C is what? Well, we're going to flip it over, which is going to be 4 over 3, and then add a negative sign to it. Okay? All right? And so let me erase something here real quick. So let me go with, let's start with a negative slope now. Let's say the slope of line A is negative 2 over 3, right? That means that the line B is also going to be negative 2 over 3. Then what happens with line C? Remember, you flip it over, that's 3 over 2, right? And since the original slope was negative, this slope is going to be positive. Okay, I hope this is all making sense. All right, so now let's go with one more, or a few more examples here of this, of equations, now dealing with equations. So let's say I have the equations, let's say, give me a second, 2y plus 3x is equal to 5, or yeah, let's say equal to 5, and 3y minus 2x is equal to 5 as well. Okay, and they're asking you, are these two equations, okay, parallel, perpendicular, or neither? So what do we need to do? We need to find the slope of each of these equations. All right, so by finding the slope, okay, once we find the slope, we could determine, right, whether the lines are parallel or perpendicular. All right, if the slopes are equal to each other, they're parallel. If the slopes are negative reciprocals of each other, right, they're perpendicular. And if it's nothing, there's just no connection there, they're not equal, there's no negative reciprocal, then they're going to hit each other sooner or later. Okay, so what do we need to do? Well, first of all, we need to know that the y is not by itself, and it's in standard form, except the fact that the x should be here and the y should be here, but that doesn't really matter because of the plus sign right here. The plus sign right here. So what do we need to do? The goal is to get the y by itself. Now, why is it important to get the y by itself? So we can find the slope. Okay. Now, there are other ways of finding slope, but I want to focus on just making sure that you understand how to get the right form of these equations. Okay, so remember, we want to get y by itself, so you subtract the 3x to both sides. Cancel that out. So 2y is equal to, remember I'm going to put the x term first, negative 3x plus 5. Then I'm going to divide by 2. And so what y is equal to, and remember when you divide, you have to do it to both numbers. Okay, so it'll be negative 3 over 2x plus 5 over 2. So what do we know about this? We know that the slope is negative 3 over 2. Okay, now let's go with the second one. We have the 3y minus 2x is equal to 5. And what we want to do again is we want to get the y by itself. So we add the 2x to both sides. And so what? 3y is equal to 2x plus 5. Then what I'm going to do is I'm going to divide by 3 to both sides. And so what? Y is equal to 2 over 3x plus 5 over 3. Okay, notice that the y-intercepts are different, right? So that we already know then that they're not going to be the same equation. And then what do? We look at the slope, 2 over 3. Well, what's the connection between 2 over 3 and negative 3 over 2? Well, we have negative 3 over 2 and positive 2 over 3. Are they negative reciprocals of each other? Yes, they are, right? Because if you flip this over, it becomes 2 over 3. And then if this is a negative, then this becomes a positive. So what do we know about these two equations? That they are perpendicular. Okay, and if we graph this, give me a second, let me graph this on the Desmos calculator just to kind of make it more clear. X plus 5 over 3. So let me share, let me get to, let's go with Desmos calculator, graphing calculator here. We go, let's put this in the equation. So y is equal to negative 3 over 2, and then put x plus 5 over 2. By the way, use a Desmos calculator well. You know, I mean, this is a great tool, very helpful. Just kind of, you kind of get familiarize yourself with it. That would be amazing because this will help you out a lot. Okay, and then we'll look at y equals 2 over 3x plus 5 over 3. Okay, so look at the lines. Notice that the lines are perpendicular, right? Okay, they cross each other at a 90-degree angle, right? And they hit each other at this point right here. So if they ever ask for the solution of a system of linear equations, okay, a lot of math is just getting past the language. Systems of equations, it sounds such a big, concept, but all it is they're just asking for the point of intersection. That's what it would be. That's the solution. Okay, but we know for the purposes of this exercise that the lines are perpendicular. Okay, let me just graph for you just real quickly. This is random, but I want to just focus on what does it mean to have lines that are parallel. Okay, well, this is negative 3 over 2x. Notice that the green line right here that I just graphed and the red line are just going along each other, but they're not going to intersect. Why is that? Because they both have the same slope and they have a different y-intercept. All right, I hope this helps. Again, feel free to ask any questions you may have. Have a good day. Bye.